Astronomy breaking news. A new space mission could save Earth from killer asteroids, but NASA keeps telling us the otherwise. According to NASA's latest report on January 4, NASA announced two new space missions to explore the solar system: Lucy, a probe that will visit swarms of ancient asteroids lurking near Jupiter, and Psyche, which will orbit the all-metal core of a dead planet. These winners of the Discovery program, as it's known, will each get $450 million to build their robots plus a rocket to launch them. This is what Discovery program missions are all about, boldly going to places we've never been to enable groundbreaking science, said Thomas Zurbuchen, the Associate Administrator of NASA's Science Mission Directorate, in a January 4 press release. But in a pile of rejected finalists, sitting alongside two conceptual missions to Venus, is a space telescope that might one day save countless lives on Earth from a killer asteroid, a threat Zurbuchen himself has said is not a matter of if but when. It's called the Near-Earth Objects Camera, or NEOCAM, and it promises to discover tens of thousands of rogue space rocks roughly 460 feet, 140 meters, in diameter or bigger. That size is by design. Congress passed a law in 2005 charging NASA as one of its 7 explicitly stated goals to find 90% of such near-Earth objects, NEOs, by the year 2020. The reason is because asteroids and comets of this size are notoriously difficult to detect, yet can slug our planet or explode in our atmosphere with more energy. Energy of at least 60 megatons worth of TNT. That's more powerful than the largest nuclear weapon ever detonated. You do that over a city, and it's a very, very bad day, Mark Sykes, director of the Planetary Science Institute and a scientist on the NEOCAM team, told Business Insider. It's important to look at your neighborhood, from a planetary defense standpoint. While NASA did commit to partially fund NEOCAM for a year, it's effectively the space agency's third pass on launching the telescope in a decade. The mission was submitted in 2 previous rounds of Discovery. Meanwhile, NASA is running years behind its congressional mandate to find NEOs, and Earth is mostly blind to threats that might one day level a city. Just this past Monday, 23rd of January, for instance, an asteroid possibly as large as a 10-story building flew past Earth closer than the Moon at 9.8 miles per second, 15.7 kilometers per second, and yet astronomers only learned of its existence 2 days beforehand. Any space rock that zooms within 125 million miles, 200 million kilometers, of Earth is considered a NEO, and so far humanity has located about 15,500 such objects. Relative to Earth, the average one is about 30 million miles, 50 million kilometers, away and moving between 27,000 miles per hour, 12 kilometers per second, and 45,000 miles per hour, 20 kilometers per second, akin to flying the length of Manhattan once a second. About 9% of these NEOs, or some 1,759 space rocks, are called potentially hazardous objects, meaning they come within 4.6 million miles, 7.48 million kilometers, of Earth. Their sizes vary wildly, so a strike could mean anything from broken windows, like the 2013 asteroid-caused airburst over Chelyabinsk, Russia, to global extinction, like the impact that helped wipe out the dinosaurs 65 million years ago. Roughly 72% of all NEOs that are 460 feet, 140 meters, or larger have not been found, according to the National Near-Earth Object Preparedness Strategy, a report published by the White House's National Science and Technology Council, NSTC, in December 2016. This amounts to about 25,000 nearby asteroids and roughly 2,300 hazardous ones. That doesn't mean we shouldn't be worried about smaller space rocks, though in fact quite the opposite. An asteroid much smaller, just 45 meters 150 feet across, exploded in 1908 over Tunguska with an explosive energy of several megatons and destroyed an area as large as New York City, Roger Blandford, a physicist at Stanford University, wrote in a September 2015 op-ed for Space News. Congress calls these smaller asteroids city killers, and although they are 30 times more numerous, we have located less than 1% of them. In raw numbers, over 300,000 objects greater than 40 meters 130 feet in size could be an impact hazard to the Earth and have not yet been detected, according to NSDC's report. Tunguska event-like asteroids strike Earth about once every 100 to 200 years, and Chelyabinsk explosions should occur as much as once a decade, according to a 2013 study in Nature. Which is why scientists desperately want to find and if necessary deflect or destroy these rogue space rocks. There's nothing out there that is anywhere near ready to detect asteroids except for NEOCAM, Sykes said. If you're a space rock, you reflect sunlight. Telescopes that are looking in the right place at the right time can see you as a dot sneaking across the blackness of space, allowing scientists to calculate your mass, speed, orbit, and the odds that you'll smack into Earth. If you're a small NEO, though you aren't very bright. This means a telescope has to be very big and use very advanced hardware to find you, but big bad telescopes are expensive and take a very long time to build and calibrate. Take the Large Synoptic Survey Telescope, LSST, for example, which is one of Earth's best current hopes of finding killer asteroids. The project broke ground in 2015 and is expected to cost upwards of $465 million to build. Based on its current construction schedule, it won't be fully operational until late 2021 at the soonest, or able to fulfill the 90% detection goal set by Congress until the mid-2030s, more than a decade behind schedule. LSST, like all ground-based observatories, also comes with two major limitations. The first, you can't see asteroids near the sun. You're blinded by the sky, Sykes said. Right now we have to wait until those pop out in front of us. To get those guys, you really need to be in space where you're not blinded by the sky. Sykes said the other snag is that ground-based telescopes mainly rely on visible light for detection. If an asteroid has a dark surface, it's going to be very hard to see, he said. NEOCAM goes after these two problems by being in space, where no atmospheric gases get in the way, and by using an advanced high-resolution infrared camera. Infrared light is a longer wavelength of light that's invisible to our eyes, but if a source is strong enough, say, a roaring fire, we can feel it as warmth on our skin. Sun-warmed asteroids emit infrared light, even when they're coasting through the void, or are too dark for ground-based telescopes to see. Which means NEOCAM could spot them by their heat signatures. The approach works. The prime example is NASA's 8-year-old Wide-Field Infrared Survey Explorer telescope, which has found at least 230 NEOs and 42 PHOs from orbit. However, it's a less powerful telescope, has a smaller field of view, an older camera that requires cryogenic cooling, NEOCAM's does not, and wasn't designed solely to hunt asteroids. While scientists gave it a new mission to do so in 2013, renaming the project NEOWISE, the telescope is scheduled to end operations in March 2017. A space-based observatory, working in concert with observations from ground-based telescopes, may be the best approach to detecting, tracking, and characterizing the NEO population, the NSDC's December 2016 report states. This combination would more rapidly complete the survey of objects larger than 140 meters 460 feet while greatly improving our understanding of the hazard from the 50 to 140 meter 160 to 460 feet NEO population. The NEOCAM team proposed to launch in 2021 and find 2/3 of missing objects in the larger than 460 feet, 140 meters, category within 4 years, about a decade ahead of LSST's schedule. Which they said, would help address the NSDC's concern on the issue. Thanks for watching. Leave your comments below and don't forget to subscribe.